Hi guys, how you doing? And it's Jalaj Aurora here again, back with another video from BHM at GCSE Chem. And today we're going to be doing the last section of chapter 2 actually. It's the final section, which is C2.6, the transition elements. So this chapter is obviously, this chapter is not much smaller, but slightly smaller than chapter 1, because chapter 1 had 8 sections and this one only has 6. One thing I want to point out is that this section is only for triple science students only. So it's only for people doing triple science It's only for students doing triple science and more specifically triple chemistry students. But I'm pretty sure that people who do triple science do all sciences. Triple basically. Hopefully you get what I mean. But basically this video is only for those students who do GCSE chemistry specifically, not combined science. So hopefully that makes sense. And if you're using the book I'm using, this is the book I use for all of my videos, and I'll be continuing to use this book. Now I've been using this book so far, and I'll be continuing to use this book for the next chapters as well, basically till we finish the content. And so let me just go back to it. So yeah, as I said, today we're learning about the transition elements, and if you're following this the student book, which is the big book, it's pages 32 to 33. And so let's start, And also, just before we start, actually, I'm really sorry about yesterday. Basically, I uploaded very late because I was very busy. I uploaded around, I started uploading around 10 past 11, so 11:10 p.m. And it finished at about 11:30 p.m., so 11:30. And basically I went upstairs and I tried to start uploading it, and it basically took more than I think it was 20-30 minutes to upload, and it basically went after midnight. So I'm really sorry about not being able to upload it before, and that's why I'm actually uploading this, to make up for that. I'm trying to upload earlier today, so hopefully this will be up on my YouTube channel much earlier, basically trying to make up for that. So sorry about that. And also again, I couldn't get my website up to date, so the links for the videos I haven't added yet, including this one. Obviously I'll be adding all of them. I'm really hoping that I can add all of them today. If not, at least by the end of the week it should all be updated. But yeah, I'll try to add them all today before we go on to chapter 3. Yes, and also one more thing before we start as well, is after we finish this, there are summary questions in this book as well. There are summary questions, aren't they? I think they're summary questions. I don't know what you call them, but they're questions at the end of the book that you can practice. Not end of the book, sorry, end of this section. After that, there's quite a few questions that you can practice regarding this chapter, which is all about this chapter basically, so you can see how well you've understood this book. That's obviously if you have this revision guide, obviously, and I've said before, it's really useful to have this revision guide and also the student book. And like I mentioned before, if you're following the student book today, it's pages 32 to 33. And so let's start. It's all about C2.6 is all about the transition elements, only for GCSE chemistry students only, triple science students only. And by the way, in my video, to denote it is triple science video, it's not for combined science, I will put in brackets TSS only, standing for triple science students only. So hopefully that makes sense. So triple science students only, to make that plural, just in case I didn't. Now let's get on with the actual section today. So the transition elements are found in the central block of the periodic table between groups 2 and 3. So obviously you have group 1 and group 2, and then you have the whole central block, which is full of all the transition elements, and then you have group 3, 4, 5, 6, 7, and then obviously you have group 0, which are noble gases. But basically they're in that's the first point, that the transition elements are in the central block of the periodic table, and they're between groups 2 and 3. So you probably know that already. And the transition elements are basically there. And the next point is that they are all metals and also called the transition metals. So you can call them transition elements or transition metals, and all of them are metals. So all of this, this entire block, I don't know, I'm circling around it, but I should probably show you which block I'm talking about. This one in the yellow, all these elements are transition elements, and these are all metals. So I was doing this, but I wasn't actually showing which one I was referring to. But basically, this is the whole kind of transition element block, basically the central block between groups 2 and 3. It's the transition elements, and all these are metals. All of these are metals, so hopefully you can see it there in yellow. So then here it says obviously the transition elements, the more well-known elements are circled. So you probably saw the circles there. I'm not going to show it again. I might as well. The elements which are circled, hopefully you can see them. You have things like titanium, chromium, iron, magnesium, tungsten. I'm not going to go through all of them. You have silver. Basically, all of these, some the common well-known elements are basically circled, and that's not very important though. Now, here's a question number 1 of 2. There's 2 questions in this. The first one in this section: where are the transition metals found in the periodic table? Also, sorry for my voice sometimes if it's a bit off. But let me repeat that question again. So, where are transition metals found in the periodic table? Well, we know the answer to that. We've just been through it. They're found in the central block of the periodic table between groups 2 and 3. And I'll just confirm that I am right, just to make sure I'm not waffling. Well, I'm pretty sure I'm not waffling, because we've literally just read it and I knew that. So let's just see that just in case. So yes, so they're in the central. Sorry about that again. In the center block, or you could say in the central block between groups 2 and 3 to be more specific. But if it's only a 1 mark, then in the center block should be fine. But just in case, I'd still add in the central block between groups 2 and 3, just to be more specific. Even if it's a 1 mark question, I would add that as well. And then, so transition elements, now we're going on to their kind of properties. So transition elements are good conductors of electricity and thermal energy. And the reason for that is obviously because we know that all metals are good conductors of, electricity and thermal energy, and, transition elements are obviously metals. So therefore transition elements are good conductors of electricity and thermal energy. So that makes sense. They are hard and strong with high densities. Now these are things you just have to remember. They're very hard metals, they're very strong, and they're very high densities. And they have high melting. They have high melting points. I didn't mention boiling points here, but they have high melting points, except for mercury. Now mercury is actually a liquid at room temperature. I'm pretty sure mercury is a liquid at room temperature. Yeah. So, that's why it says with the exception for mercury, they have high melting points. Is mercury a liquid or a solid? Wait, let me check that actually. 1 minute. I don't want to give the wrong information. So, 1 minute. Sorry about that. Let me just check this because I don't want to give away any wrong information. Mercury. Let's see. Yeah, it says that mercury is the only metallic element that is liquid at standard conditions for temperature and pressure. That's fine. Yeah, I was right. Mercury is a liquid at room temperature, or standard conditions of temperature and pressure. So, yeah, sorry for having to check it, but I just wanted to make sure. Sorry for the delay there, but I had to check just to make sure, as I mentioned before. So yeah, they have, I said they have high melting points except for mercury, which is obviously a liquid at room temperature, or standard temperature and pressure. And that makes sense, obviously, because what is melting point? The melting point is the temperature at which something turns from a solid to a liquid. And because mercury is a liquid at room temperature, which is about, I think, 25 degrees Celsius, I'm pretty sure, or 298 Kelvin if you convert it to Kelvin by adding 273 to that. But because it's only at room temperature, that means it doesn't really have a high melting point. It has quite a low melting point because room temperature is not very high temperature. Excuse me there. And then the transition elements have high melting points compared with group 1 metals. That's something you need to learn as well. They have high melting points when they're compared with group 1 metals. Transition elements are harder, stronger, and much more dense than group 1 metals. We already saw that transition elements actually have high densities. They're stronger and they're harder, and they are much more dense, but they're much more dense than group 1 metals as well. Yep, and then transition elements are much less reactive than group 1 elements. Transition metals only react slowly or not at all with oxygen and water. At ordinary temperatures, iron reacts much slower than chlorine gas in group. Iron reacts much slower with chlorine gas than group 1 metals do. So basically, you're saying that although transition metals are harder, stronger, and more dense than group 1 metals, or the group 1 elements, you can call it either, they're still metals and they're elements as well. They're still, transition elements or transition metals, they're still very, they're much less reactive than group 1 metals or elements. They, transition elements, they don't react very fast, like they are very slow reactions with water and oxygen. When you, and for example with halogens as well, iron reacts with chlorine, in a much slower reaction. Iron reacting with chlorine is a much slower reaction than group 1 metals, any other group 1 metals reacting with chlorine. So basically they're less reactive, so transition elements or transition metals you can call them are much less reactive than the group 1 elements or group 1 metals. I'm just going to say both just for your reference, but they are stronger, harder, but transition elements or transition metals are much stronger, harder and denser than group 1 elements. So here it says name the ways in which transition elements are different from elements in group 1. Well, we just saw that. Well, transition elements are harder, they're stronger, they're more dense than group 1 metals, group 1 elements. But they're much less reactive than transition elements or transition metals are much less reactive than group 1 elements and or group 1 metals. I don't think I'm going to say both now, elements and metals. I'm just going to say maybe elements now. I'll just say elements. Yep. So that's basically the ways they kind of differ from group 1, do transition elements. So that's the ways that transition elements differ from group 1 elements, and you can just mention some of them. And you can, when you say that transition elements are less reactive than group 1 elements, you could also say that they what do I have to say? Yeah, that they have slow reactions with water and much slower reactions with water and oxygen, and even with halogens when compared to that of the reactivity of group 1 metals or group 1 elements, I'd say, with the same kind of things, water, oxygen, and halogens. So I'm just going to stick with elements now, and for the remainder of the video, not say metals and elements, even though they're both So that should be the answer. I'll just go through that. I'll just see if I'm right. I probably am. Let's see. I probably am. Let's see. So obviously, yeah, high melting points. Oh wait, I forgot to mention that. Yeah, transition metals, they have high melting points. Remember when we said that group 1 elements, their melting points actually decreases going down the group. So yeah, so that's a good thing to mention as well, that they have high melting points. And the rest, I think I mentioned, they're stronger, harder, denser, they're less reactive with oxygen and water. Ions have different charges, and coloured compounds and catalysts. Yeah, the reason why I didn't mention that yet was because we haven't got to that yet, because I knew that, but I haven't mentioned it yet. But it's coming here actually. Transition elements form positive ions with variable or various charges, for example Fe2+ and Fe3+. So that's another distinction. Group 1 metals, or I'd say group 1 elements now. I said I'll only mention elements, so I'll just stick with elements now, even though they're metals as well. Group 1 elements, they can only form 1+ ions, but they can only form single ions basically. But transition elements, they can form various ions, ions with their various charges. So like for example Fe, so iron can form Fe2+, iron 2+, and iron 3+, which is Fe3+. Another difference is obviously compounds of transition metals are often brightly coloured. You can remember that as well. And then many transition metals and their compounds are catalysts for chemical reactions. So transition metals, they can actually be used as catalysts, and their compounds can also be used as catalysts. Like some examples are, for example, you know the iron catalyst that you use in the Haber process, and also the vanadium oxide catalyst you use in another reaction, which I don't remember. I don't think it's in my A-level specification. I just sort of remember from somewhere that you use a vanadium oxide catalyst for something. But basically, what the point I'm trying to make is that, you know, transition elements can act as catalysts, and their compounds can also act as catalysts. So that's another distinction between group 1 and transition elements. You know, transition elements can act as catalysts, unlike group 1 elements. Yeah, I don't think group 1 elements can act as catalysts, like definitely doesn't mention it in the book. And also transition elements can form colored compounds. We've seen that as well, that, you know, they're you know, compounds of transition metals are often brightly colored, and they can obviously form ions with various charges. Oh, sorry about the noise there. Unlike group 1 elements that can only form 1+ ions, so single, you know, kind of only one ion, which is the 1+ ions basically. Now, a couple of things as well here is that for more information, so here's synoptic links. For more information on bonding and structure of metals, see topics C3.9 and C3.10. So again, from tomorrow we're starting chapter 3, so we're gonna see that later on. That's quite far into the book, actually, you know, quite far into the chapter, like the last few bits of the chapter, C3.9 and C3.2, so C3.9 and C3.10, apologies. And another synoptic link here, it says that catalysts are covered in topic C8.5, so that's far away, but we're going to get to that. And study tip here is the charge on the metal ion is given by the name of many transition metal compounds. For example, copper 2 sulfate, CuSO4, contains Cu2+, whereas copper 2 oxide contains, which is Cu2O, contains Cu+ ions. So basically here's a good thing to actually mention. Hopefully you can see it. You can see how they write it in Roman numerals, like they write thing in Roman numerals. Hopefully you can see it, like here. Here they write Roman numerals between the two, kind of between the compound, in the middle of the compound, and then they write it here as well. Where else? Well, hopefully you can see that one there if I get it closer. Yeah, hopefully you can see that one there, and also that one there. So hopefully the ones in brackets, you can see it. Basically, whatever numeral you put in the brackets tells you the charge of the ion. And they're in questions, they're most likely going to give you the kind of compound, and you're probably going to have to write the word of the, you know, how you'd write it in words with the charges given by Roman numerals in brackets. So that tells you the charge of the transition metal. Or transition element, you could say. Keywords here are transition elements. So that's basically what we're talking about mainly in this one, is transition elements. Also, I don't think I mentioned this, but basically there were no keywords in C2.5 explaining trends, but there is a keyword here in C2.6 which is all about, you know, transition elements. That's the keyword, transition elements. Now, before we finish off, let's just go through the key points basically quickly. So compounds with the alkali metals. Wait, sorry, what am I saying? No, let's say that again. Compared with the alkali metals, transition elements have much higher melting and boiling points. Have much higher melting points. Don't say boiling points, because it only mentions melting points in the book. So compared with alkali metals, transition elements have much higher melting points and densities. They are stronger and harder, but much less reactive. Then we go on to another point, which is that the transition elements do not react vigorously with oxygen or water. We know that they're less reactive than group 1 elements. We've just gone through that as well. And a transition element can form ions with different charges in compounds that are often colored. So they often form colored compounds with different charges, with various charges. We went through that as well. And finally, transition elements and their compounds are important industrial catalysts. So we said that transition metals and their catalysts and their compounds can be used as catalysts in industry. You know, industrial catalysts they can be used for, like in the Haber process, for example. And we're going to learn more about the Haber process in, I don't know when it is, but I think it's in chapter. Okay, I'm not going to say the chapter name because I'm not sure. But basically, yeah, we're going to learn about it very later on. Like, I think it comes in the last few chapters of the book. But basically, that's the end of the section, and I think I'll end the video here. I'll try and, you know, put this, upload it now. I'll upload the video now, and I'll try and put the link to this video and the videos, the videos before this that I haven't put on my website. I'll try and do that today, and tomorrow we'll be starting chapter 3, which actually I think is one of the biggest chapters or longest chapters in the book. It has 12 sections, so that's quite big. But yeah, I mean, it's on C3 is all about structure and bonding. But we finished chapter 2, and just to finish off as well, because I think I mentioned it before, but let me just say, now if you have this book, you can obviously try out these questions just to make sure, you know, on this page now, on page 15, you can try out the questions that are related to chapter 2, so that you can see if you fully understand it or you need to go over some things. And yeah, so that's all for today. Make sure to share, like and subscribe, turn the notifications on if you haven't already, so that you're notified and updated when I upload new videos that you can watch. I'm trying to upload a video every single day, and so far I have been able to. And yeah, until next time, see you guys, and thank you very much.